in general, the movement actuator amplitude from a range to 30 to 25 millimeters. One thing that was seen is that the smaller the amplitude, the higher the forces and torques in general. Here, those are represented by the red line, the smallest amplitudes. Something else that was seen was that, for example, in this case, the only thing being varied is the central rod. Therefore, the only forces and torques that are seen affected are the ones that are in that plane. For example, the central roll, like T2, is the one that is only affected because it's the force in the y direction. And its relative bending moment, which is the moment in the x-axis, is the ones that are affected. But the other two are not affected because they're not on that plane. In general, when varying the lateral motion, the opposite is seen. This is logical because the variations happen depending on which plane you're doing. The same behavior was seen here also between the force and between T1 and R2 that are like forces and torques that are related by their lever arm. They have the exact same response. And actually, when making the division, it's always a constant lever arm that differentiates them. This makes sense because it's like always the right-hand rule between the weight of the user moving and the force of the fail, producing the failing of the forward, the joint mentioned. In general, both Robotype console models were considered to be accurate because the results obtained were logical with the height, with the displacements, and with the forces and torques in Robotype. Human movements was the factor that proved to be the most critical and the most influential in the entire modeling. The motion seat was not considered to be safe. Like as of now, the report for the enterprise said that it's not considered to be safe. Certain geometrical considerations or modifications will have to be made on the model before it's approved. And the coupling itself was considered to be valid because the displacement field obtained was small. What I mean by small is like relatively small when compared to the other dimensions of the structure and when compared to the movement of the human itself, for example, when compared to the movement of other bodies in the same structure. And in general, co-simulation between both sides.
There seems to be an inconsistency in page 59 where you are describing these conditions that apply to your finite dimension, and where you are speaking about distributed stresses, as I understand, on the top.
Yeah.
And then on page 70, there you
70?
see 70.
Okay.
You say that the displacements on the top surface, as I understand it, you see that the surface is rigid. So what is it in the end? Are you describing stresses or displacements?
Well, in page 59, what I was explaining the boundary conditions is the limit that we're referring to. But in general, this didn't fail by a little bit, because one thing that I say in the conclusions is that if it would have failed closely, then we can say that we're making many stress overestimations by saying that the place is fixed, for example. That's an overestimation. What are taken to be the origin and what the values of those masses are. That's very centric, origin-centric. Well, that's what I want to understood. In general, I was going to show you what I meant between the relationship of R1 and R2 is that when you divide R1 by T2, you always get a constant number, which is the distance of just standing here in the base and adding up on the model itself, adding up all the geometry regarding this z-axis. It's pretty close to the center of mass of the human, which, given that its weight is 180 kilograms and the other structures are not even close to that weight, it's probable where the barycentric origin is going to be of this.
Last word for the... Moi, je ne parlerai ni en anglais ni en espagnol, c'est pourquoi, surtout pour l'espagnol. Et voilà, je posais une petite question. Je n'ai pas très bien compris. Je vais poser la question à l'espagnol, on va parler en français pendant Ah non, du tout. Et you are forced to do that. Pourquoi tu parles de time step?
Of course, it's sinusoidal. If a time step takes, for example, it can do the 5 seconds in 3 steps and just take the minimal places. So I wouldn't really get the most critical response. In order
but in Robotron, you control the time step so that to reach the maximum over there. You do
yeah.
Because you know the frequency of your system, because you put.
Yeah, in control you put the time step. And you get a set of forces that depends through time and it changes sinusoidally through time. Then when you put those in console, the console modeling will not take, it will not just take each time step you put in console.
So
it has its own solver.
It's a technical problem within console.
Yes.
Isn't it?
It has its own solver. So in order to guarantee that it takes the peak values, that's why the time step variation.
Okay.
Okay. Thank you very much.
You're welcome.
Non, l'assistant là.
Attends, c'est pas l'assistant. Non, je vais assister l'espagnol, mais assistente favorito.
Ah, l'assistante favorito. No.